Algebra 2. How's it going? It's week 4. You're doing great. It's assignment 2. Keep it up. Show me work. You're doing great. Let's get rolling. Rational functions. We're still talking about those, and we're going to see how to rewrite some more complicated ones so it makes it easier to graph them. First, I want to go over just a bunch of review that's going to help us with this. When we're looking at functions, rational functions, just remember that they're in the form of f of x equals, so whenever I think of rational, I always think of fractions. So a rational function is literally like a fraction of other functions, okay? This is a function being divided by another function, all right? Some examples of rational functions, well, we had the good old parent function that looked like that, 1 over x. 1 is technically considered a polynomial. X is considered a polynomial. We could have x plus 3, that's like a function divided by 2x minus 1. That's another function, right? And here's a function being divided by another function. This is a rational function altogether. We could have x squared plus 2 divided by x cubed plus 3x plus 1, right? Function divided by another function. These are all examples of rational functions. We'll get to these crazier ones later, but we're going to focus on some easier ones. Notice how at this crazy one we have some exponents here. In these easier ones that we're looking at, these ones today, these are like linear functions being divided by each other. So we're just going to look at some very simple ones. And yes, so how to rewrite functions to graph them easily, all right? So again, as I said, if you look at this, again, there's no numbers put to it, but you can see that it's a linear function. This value or this variable of x on the numerator and the denominator, it's not being raised to any exponent, right? There's no squares or cubes or to the 4th power. These are just straight up linear functions. So I want to see how to take a linear function that may look something like this and be able to write it in this form, okay? Because from right here, I can't see any vertical asymptotes. I can't see any horizontal asymptotes. I don't know anything about the domain and range. This is hard for me to graph. But in this form, I can see, oh, okay, here's my vertical asymptote. I set that denominator equal to 0 and solve for x. Over here's my horizontal asymptote, which would be like y equals c, whatever's being added or minused on to the end. I can see some vertical stretches. This form is a lot easier to graph. So how do I go from here to here? Well, woohoo, long division. All right, we're going to bring back long division of polynomials. So just a quick reminder of how this all works, all right? Long division reminder. You've got a dividend, and it's being divided by the divisor. Okay, and then when you divide those two things, you're left with the quotient, right? The quotient is how many times does the divisor go into the dividend, and you may have a remainder, okay? And you add the remainder on at the end, so plus remainder, but you got to put it over the divisor, all right? So I'm going to just do a simple number 1 just so we remember how this goes, and then we'll look at doing this with polynomials. So again, here I've got my dividend of 50. I have my divisor of 7, all right? And if I'm going to use long division, so I'm going to kind of scoot this down to the bottom here and say 7. I'm going to set up a long division here. So 50 divided by 7. Okay, and then I can go through these steps that we've been doing since 3rd grade or 2nd grade. 7 goes into 50. How many times? Well, I know it goes in at least 7 times because 7 times 7 is 49. Okay, and then 7 times 7 is 49. And then I subtract and I get 1. And then I have that remainder there, right? So you would add on, this would be your, hang on, I'm going to do this again. So here's my dividend. Here's my divisor. My remainder, or excuse me, my quotient, let's go with quotient. My quotient here is 7, and my remainder is this 1, but I have to put it over the divisor again, right? So 50 divided by 7, we could write that as 7, my quotient, plus my remainder of 1 over my divisor, which again is 7, all right? take a second. I'm going to color coordinate that so we all see. Here's my quotient of 7, my remainder of 1 being put over my divisor again. And if you do 50 divided by 7, you'll get 7 1/7 on your calculator. Alrighty, so we're going to start looking at how this applies to long division with some polynomials. I have a polynomial 2x plus 3. It's being divided by a polynomial of x plus 1. I want to simplify this so I can get it into an easier form so I can recognize some key features that are going to help me graph it. So when I divide these two things, I'm going to be looking for a quotient, I'm going to be looking for a remainder, and I'm going to have to put that remainder over a divisor, and just trust me here, follow the process, it works, all right? So I'm going to start with long division here, and I'm going to set up my polynomial long division by saying my divisor of x plus 1 on the outside, and then 2x plus 3. You may need to do, I'll find a good video for long division of polynomials and I'll attach it to the video if you need some review. Otherwise, I'm going to just keep going. So basically what I'm asking is, what number do I have to multiply x by to get 2x? Well, I would have to multiply it by 2. So I'm going to put the 2 at the top here. And again, I don't have to multiply by another x to make it x squared or anything. It's just a linear function. It just has a degree of 1, right? So I don't need to add another x in there. I just have to multiply it by 2, and that's why I'm lining up the 2 with this other constant 3 on the outside, okay? I'm lining up the degree with the same degree. So this 2, then I can multiply it to this entire divisor here and say, all right, well, 2 times x plus 1, so that's going to be like distributed, so that's going to be 2x like we planned, plus, and then 2 times 1 is 2. And then just like we do with long division, I subtract this. So I'm going to put parentheses around all of it so I know I need to subtract all of it. Put my little subtraction sign out there. 2x minus 2x is going to cancel out and be 0. And then I can look at this last one and say, all right, 3 minus 2 is just 1. Oops, it is just 1 there. So from this information, zoom out. Okay, from this information, I can see my quotient of 2, and I can see my remainder of 1. Now I can write this just in this form here, okay? So I'm going to follow this. I'm going to say my quotient of 2, so 2, and then plus my remainder divided by my divisor, my remainder of 1 divided by my divisor of x plus 1, all right? And there's my function, right? I mean, we just use long division to simplify this thing. This right here is the same as this, but would you agree that this is a lot more easier to graph? So I don't have any graphs for you right now, but let's just identify the key features from this. So what I'm asking you to do is to figure out what the vertical asymptote would be. Again, that is setting your denominator equal to 0 and solving for x. So I'm going to do that. I'm going to say x plus 1 equal to 0. If I solve for x here, I'm going to minus 1 from both sides. I'm going to have a vertical asymptote at -1, at x equals -1. So there's going to be in this graph, there's going to be a vertical line at x equals -1 that my rational function cannot cross or meet, all right? I'm also going to ask you for the horizontal asymptote, all right? The horizontal asymptote is y equals, and then if you remember, it's whatever is being added onto the outside, right? So it's just 2 being added on. It's a positive 2, so y has to be equal to 2. There would be my horizontal asymptote. I would have a horizontal line at y equals 2 that my function cannot cross or meet. And then the other things I want you to do are also identify the domain and range. So domain, we're just going to use set notation from this, all right? So domain is all my x values, but from my vertical asymptote, I saw that my x cannot be equal to -1 because I have an asymptote there, right? So my domain, all of the x values such that x is not equal to -1, My range works the same way, but now with my y values, all my y values such that y is not equal to -2 because I have a horizontal asymptote at 2. Oh, I'm sorry, -2, no, +2. There we go. All right, so let's do another one. Again, if you need to have that written down somewhere so you see, keep that example with you. Let's move on to our next example. So a function, this is a rational function, g of x equals 3x minus 4 divided by x minus 2. I want to graph this, and I really want to find some key features of this so I can graph it easier. But I got to get that in that easier form, so we're going to use long division again. So here is my dividend. Here is my divisor. So I'm going to say x minus 2 on the outside. On the inside is that 3x minus 4. Now I can start my long division so I can see my quotient and I can see my remainder. So I have to multiply what times x would give me 3x. Again, we look at just that first part of whatever we're dividing. Well, 3 times x would give me 3x, so I would have to multiply by 3. And then I can say, okay, 3 times this entire divisor, that would give me 3x, kind of like what we planned. And then 3 times that -2 is going to be -6. And then I have to subtract all of that off. And just like what we saw, this 3x minus 3x is going to cancel out and be 0. And then I have -4 minus -6. If you need to write that off to the side, you totally can. -4 minus -6. I see I have 2 negatives there, so those technically turn to positive. So now I have -4 plus 6. That gets me a +2. All right, and then there's nothing else. I've kind of ran out of stuff to do, so now I can see my quotient and I can see my remainder. All right, so I'm going to come up back to the top and I'm going to rewrite this and say, okay, my quotient is 3 plus, and then my remainder of 2 divided by my divisor of x minus 2. All right. Hey, that is a lot easier to graph. Let's identify some key features for it. So again, my vertical asymptote, my horizontal asymptote, my domain, and the range are the 4 things I'm going to be asking you for. The vertical asymptote, again, we set our denominator equal to 0 and solve for x. So x minus 2 equals 0. I'm going to add 2 to both sides. X equals +2. And technically, if you notice, right, it's just the opposite sign of that. So if you have x plus 5, your vertical asymptote would be at x equals -5. If you had x minus 5, then you'd have a vertical asymptote at x plus 5. Anyway, my horizontal asymptote is whatever's being added onto the outside. So that would be y equals 3. My domain, all of my x values, but again, I have to keep the idea of my vertical asymptote in mind. So all of my x values such that x is not equal to 2. Again, because I have a asymptote at x equals 2. Can't be equal to 2. It can't cross or meet that invisible line. We're just going to be throwing out that value of 2 in our domain. Our range, same thing with our y's, so it's the set of all y's such that y is not equal to 3. Again, I get that just from my horizontal asymptote. All right, let's do one more. Oh, and I also want to point out, this 2 on the top, it's not going to be changing my vertical asymptotes or my horizontal asymptotes because it's like a vertical stretch, right? If you wanted to, so down off to the side, I'm going to say 3 plus 2 over x minus 2. If you wanted to, you could factor out that 2 from this entire thing and say that this is just equal to 3 plus 2 times 1 over x minus 2. And you see that, again, it's not going to change anything. It's really just a vertical stretch, all right? It's just a 2 being multiplied on the outside. Okay, let's do another one. G of x equals 4x plus 4 divided by x plus 10. Again, I want to write this as quotient plus remainder over divisor. We're just going to use long division. So I'm going to set up my long division and then 4x plus 4 on the inside. So what do I have to multiply x by in order to get 4x? Well, I'd have to multiply it by 4. Take that 4, multiply to the entire divisor here. So 4 times x plus 10. That's going to give me 4x plus 40. And then I have to subtract. So I'm going to subtract everything. The 4x minus the 4x is just going to cancel each other out. And then I have 4 minus 40. And that gets me negative 36. And that's what we got. That's our remainder here. So I'm just going to circle that. I've got a remainder. I have my quotient. So now I can rewrite this thing and say, okay, my quotient of 4 plus my remainder of negative 36 over my divisor, x plus 10. Okay, and then from there, we can identify a whole bunch of stuff. Again, I'm going to just bring this down. So this is really g of x equals 4 plus negative 36 divided by x plus 10. If you wanted to, you could factor out that negative 36 and just write it as 4 plus negative 36 times 1 over x plus 10. Again, that negative 36 is just doing a vertical stretch. And since there's technically a negative in there, it's really going to be doing another reflection across the x-axis. But it's not going to be changing our horizontal asymptotes or our horizontal asymptotes or the vertical asymptotes. Oh my goodness, that was the other one. See, we're just going to keep rolling. Okay, so my vertical asymptote from this thing here, right? Let me just get the rest of them down. Horizontal asymptote, my domain, and my range. So vertical asymptote, take your denominator of x plus 10, set it equal to 0, and solve for x. I'm going to get x equals negative 10. My horizontal asymptote, again, is whatever's being added or minused onto the outside. So here I see that there's a positive 4. So I'm going to have y equals 4. Domain, all the x values such that, take a look at your vertical asymptote, x cannot be equal to negative 10. Range, the same with our y values. All the y's, the set of all the y values such that, take a look at your horizontal asymptote, your y cannot be equal to 4. All right. So make sure you can identify these key features here. I'm not going to be asking you to graph them. I may ask you like what kind of graph would go with this thing, but I'm not going to actually ask you to graph it because I know a lot of you type it out and I don't want you to have to do too much technologically stuff to figure out that I don't know what I'm talking about anymore. Okay, I'm tired. We're gonna have a nap. Have a good day, guys. Let me know if you have any questions. Using long division, find your quotient, find your remainder, be able to identify vertical asymptote, horizontal asymptote, domain, and range. Enjoy life. Adios.